In this video, we are going to learn about local extremes and critical points. So first, I will take you through the critical points. What are critical points? When we talk about critical points, we talk about the points at which the derivative of a function with respect to each variable is zero. So let us first look at the following function. F of x, y is given by x e to the negative x squared over 2 minus y to the third over 3 plus y. So we want to first learn to determine the critical point. Determine the critical point of the following function. As we know that we want to find the point at which the derivative of this function will give us 0. So this is a function x and y. So it means that first we have to find the derivative of this function with respect to x. Then let's say we find f sub x. So when we want to find f sub x, we are going to differentiate this function with respect to x. And then let us first look at the following function. We have x and e to the negative x squared over 2 minus y cubed over 3 plus y. So since when we check, here we have x, and then in the second term, e to the negative x squared over 2, we also have the variable x. Then for us, in order to differentiate this particular problem with respect to x, it means we have to differentiate using product rule. Then first I will keep x. Then by keeping x, it means then now I am going to differentiate this part with respect to x. And then can we differentiate this part with respect to x? This is a natural log. Then the derivative of this function is e to the negative x squared over 2 minus y to the third over 3 plus y. Then multiply this function by the derivative of whatever is at the top. So the derivative of this is minus 2x squared over 2. And then we differentiate this part with respect to x. Since there is no variable x, this is a 0. And then also this part, there's no variable x, it will give us a 0 like that. Then it's a product rule. Then plus, then we keep the second term, e to the negative x squared over 2 minus y to the third over 3 plus y. Then we multiply by the derivative of the first term. So the derivative of f of x with respect to x is nothing but a 1. We have said that the derivative of this function must give us 0. Then we can proceed to say now we have x e to the negative x squared over 2 minus y to the third over 3 plus y. Then 2 will cancel 2, and then what will remain is negative x. The square, there's no squared here because when we multiply the coefficient of x, then we subtract 1 from 2, 1 will remain. Then we'll just have a negative x like this plus e to the negative x squared over 2 minus y to the third over 3 plus 1. We have said that the derivative of this function must be a 0. Then we can rewrite this equation in this form. X can multiply x, and then we will have negative x squared e to the negative x squared over 2 minus y cubed over 3 plus y, and then plus whatever we have here, e to the negative x squared over 2 minus y cubed over 3 plus y. And then we equate everything to 0. And then from now on, when we check on this problem, we have a common factor, which is the natural log e to the negative x squared over 2 minus y cubed over 3 plus y. And then we can take it out as a common factor. Then we'll have minus x squared over 2 minus y to the third over 3 plus y. Then when we take it out inside the bracket, minus x squared will remain, and then plus 1 for this part. Then this is nothing but a 0. We want to find the critical points for f sub x, and then we can divide by this part both sides. And then if we divide by this part both sides, then on the left we'll have minus x squared plus 1 equated to 0. And then this can be rearranged in this form or divide throughout by negative. So it means we'll have x squared minus 1 equal to 0. And then you can take 1 to the right if you like, or you can factorize. But for now, let me take 1 to the right. Then it means x squared is nothing but 1. We want to find x. So we take the square root both sides. X is equal to plus or minus the square root of 1. Then the square root of 1 is just a 1 like this. So this is the first point for f sub x. And then we also have to find f sub y, because it's a multivariable function, which is the function x and y. And then now let us look at f sub y. F sub y must give us a 0, because these are critical points. The derivative must give us 0 always. Then let us now differentiate this function with respect to y. When we check, the first term is x, and the second term is the natural log e to the power everything, which we have here. Since the first term is x, is not y, and then we want to differentiate with respect to y, then this time around we are not going to use the product rule. We are just going to directly differentiate this function with respect to y, and then we will keep x as neutral. Then it means we'll have x e to the negative x squared over 2 minus y to the third over 3 plus y. Then we multiply by the derivative of whatever is at the top with respect to y. Then here we do not have the variable y. It means when we differentiate this part, it will get 0. And then also this one, here we have y. Then we can differentiate this side. Then we differentiate this side, 3 will multiply the coefficient here, and then this 3 will cancel this 3, and then at last we'll have y to the squared. Then plus we also have to differentiate the y. The derivative of this is nothing but 1 like that. Then this is equal to 0. And then we want to find the values of y. Then we can divide by this part both sides. So on the left we will have minus y squared plus 1 equal to 0. And then we can divide throughout by negative. When we divide by negative, it means now we have positive y squared minus 1 equal to 0 like this. So we can take 1 to the right. So when we take 1 to the right, we'll have y squared equals to positive 1. And then taking square root both sides, it means y is equals to plus or minus 1. So we want to write these points in the form of critical points. How then can we write them in the form of critical points? We come here and say we have the values of x as positive plus or minus 1. It means when x is positive, we can have the value of y, which is also positive. This is our first point. Then again, we can have this point when x is positive, we can have the value of y this side as negative. This is our second point. We also have the point when x is negative, we can find the value of y as positive. So then, and lastly, we have the point when x is -1, we can find the value of y as -1. So these are our critical points. Then we can have another example. Let me say now we want to find and classify the stationary points of the following function. So we are given the following function f of x, y, which is equal to x cubed plus 3y minus y cubed minus 3x. We want to find the stationary points and classify them. So we have said that we want to find the stationary points. The stationary points are the same as the critical points. So we want to first find f sub x, which is to give us a 0 like this. And then we differentiate this function with respect to x. When we differentiate it with respect to x, it means we are going to get 3x squared. Then there's no x here, it's a 0. There's no x here, it's a 0. Then we differentiate minus 3x with respect to x. So it means we'll have minus 3. We equate this to 0. Then we can divide by 3 throughout because 3 is common. So we'll have x cubed minus 1 equal to 0. And then from this we can take 1 to the right. When we take 1 to the right, we get x squared equals to 1. Then we take square root both sides. X is nothing but equal to plus or minus 1. So that's it for f sub x. Let us now find f sub y. So f sub y, it has to give us 0 because the derivative of this function with respect to each variable has to give us a 0. So I'm going to differentiate this function with respect to y this time around. So the derivative of x cubed with respect to y is a 0. Then the derivative of 3y with respect to y is a 3 minus the derivative of y minus y cubed. So this is minus y minus 3y squared. There's no y in this term, therefore it's a 0. Then we can equate everything to 0 like this. Then we can also divide by 3 because 3 is common. Then it means we'll have 1 minus y squared equal to 0. And then from this we can take 1 to the right. And then when we take 1 to the right, it will become negative. Then on the left we'll have minus x squared, which is equals to -1. So we want to find y. Let us first divide by negative. When we divide by negative, y squared is equals to +1. So the value of y will be given by plus or minus 1. Then let us write our stationary points. So we have the stationary points when x is +1, then y can also be +1, and then now when x is +1, y can be -1, and then again when x is -1, y can be +1, and lastly when x is -1, y can be -1. These are the stationary points. But the question is not yet complete because when we check, we have to find the stationary points and classify them. So how then do we classify our stationary points? We are going to classify our stationary points as they are either maximum, minimum, or a saddle point. For us, in order to determine whether a point is a minimum or maximum or a saddle point, we have to go through some steps. Then let us look at the following. If it happens that when we find f of x, or second derivative of f sub x, then only to find that the value is greater than 0 and the value of d at a point x and y, we find that the value is also greater than 0, it means that point is a local minimum. Then if it happens that we find the value of x sub x and at the point a and b, or x and y, which are this point, then we find that this value is less than 0. However, d at x and y is still positive. Then we call this point a local maximum. And lastly, if we happen to find that d at x and y is negative or less than 0, this point is neither a minimum or a local minimum or a maximum, then we'll call it a saddle point. We will need this information in order to classify our stationary points. Then first we are going to take our points one by one. Let us first look at the point then f of xx, or the second derivative of f with respect to x. So we're going to differentiate this part, and then now we're going to have 6x, and derivative of minus 3 with respect to x is a 0. Then after doing that, we are going to substitute the values of x and y in this point. So it means f sub x at a point 1 and 1 is given by x, is given by 6, and then the value of x is 1. So we get 6, and 6 is greater than 0. And then secondly, we want to find d at a point x and y, and d is given by f sub x, f sub y minus fx and y squared. So far, we found the value of f sub x, or second derivative of f with respect to x. Then it means we also have to find the second derivative of y with respect to y. Let us now find second derivative of f with respect to y. Then the first derivative of f with respect to y is this part. Then we differentiate it again. So this is a constant. When we differentiate a constant, we get a 0. Then now we differentiate minus 3 y squared. All we get is minus 6y. And then lastly, we substitute the value of 1 and 1. So this is x and this is the value of y. Then we substitute into the equation. Minus 6 times 1 is minus 6, and minus 6 is less than a 0. So we are done with this part. Now let us come to this one. Then now we want to find fxy. So how then do we find fxy? Then f of xy is given by, this is the derivative of x, and then we differentiate it for the second time, but this time around with respect to y. So the first derivative of f with respect to x is this one. And then now we differentiate it with respect to y. So there is no variable y in this equation. Therefore, it means this equation is nothing but a 0. Then we can now substitute our values in this equation. So the value of x is 1, the value of y is 1. And then f of f sub x. So this is the point, we have 6. And then second derivative of f with respect to y, we found minus 6. This is minus 6 minus, then this side we have a 0. 0 squared. 0 squared is a 0, does not change. And then 6 times 6 is 36. So since we have a negative, it means the answer is minus 36. And minus 36, when we check, is less than a 0. Remember the conditions. Then we check f sub x. We have a number which is greater than 0, and then this part is less than 0. We have said that when we have d at a point x and y is less than 0, we say that point is a saddle point. So it means this point is a saddle point 1 and 1. We are done now with this one. Now let us look at the second point. Let me put this aside and then so that I can have a clear view of the previous equations. Now we are going to look at the second point, 1 and minus 1. We perform the same process. So we have to go through f sub x, and then at a point 1 and minus 1. And then we have agreed that f, second derivative of f with respect to x is given by 6x as we found, and then the second derivative of f with respect to y is given by minus 6y, and the fxy we found 0 this side. Then we are going to perform the same process. Now let us say we want to find fxx at 1 and minus 1. So this is our equation. It means 6, where there is x, then we are going to substitute the value of 1. Then we have 6, and we check 6 is greater than 0. And then we come to f of yy at a point 1 and minus 1. This is equals to minus 6, and then the value of y is minus 1. Then this is minus 1, and then minus 6 multiplied by minus 1 is a positive 1. And then it means now we can find d at a point 1 and minus 1. So we've said that the equation is to be f of xx, f of yy minus f of xy squared. When we check, f of xx is given by positive 6. So this is 6. We multiply it by f of yy, which is given by a positive 6 also. So minus a 0. So 6 times 6 is positive 36. Then this time around, when we check here, positive 36 is greater than 0. And the second derivative of f with respect to x is also greater than 0. Then it means the point 1 and minus 1 is a local minimum. So now we are done with the second point. Let us look at the third point. So the point minus 1 and 1. We perform the same process. Then fxx, we're going to substitute minus 1 and 1. Then this is our equation 6x. Then we substitute x we substitute the value of minus 1 where there is x, so we'll have minus 1, and then this is nothing but minus 6, and minus 6 is less than a 0. And then secondly, let us have f of y at a point minus 1 and 1. This is our equation, minus 6, and then y is positive 1, so this is negative 6. And lastly, we can find our d at a point minus 1 and 1. Then f of xx this time around is minus 6. So we have minus 6. We multiply it by f of y. We have minus 6. This is minus 6. Minus 6 multiplied by minus 6 is positive 36. Positive 36 is greater than 0. Now we want to classify this point minus 1 and 1 as either a local minimum, a maximum, or a saddle point. When you check, f second derivative of f with respect to x is less than 0. However, the value of d is greater than 0. It means now this point is nothing but is a local maximum. It's a local maximum because f sub x is negative 6, and negative 6 less than 0, then this one is greater than 0. So if this value here is greater than 0 and d is also greater than 0, it's a minimum. And then lastly, we can look at the point minus 1 and minus 1. And then we want to find f(x)(x) at minus 1 and minus 1. This is our equation, 6x. And then we substitute the value of negative 1 where there is x. Then it means we'll have negative 1. And then negative 1 multiplied by 6 is negative 6. This is less than a 0. And then secondly, we look at the second derivative of f with respect to y at a point minus 1 and minus 1. So this is the equation, minus 6y. Then where there is y, we plug in minus 1. So we multiply the 2, we get positive 6. And then this is greater than 0. So our d at the point minus 1 and minus 1 is given by f of xx. This is our f of xx, which is negative 6. And f of y is positive 6 minus a 0. Negative 6 times positive 6 is negative 36. Negative 36 is less than a 0. Then now we can conclude by saying that the point negative 1 and negative 1, since the value of d is less than 0, it means the point is a saddle point. So that's it for this video. I hope you enjoyed. Don't forget to subscribe so that you can also get updates when I post new videos. Thank you.